Hello my dear all students, I am Rajika Wimalarathne. This is your online English medium combined mathematics class. Today is the 8th day of your combined mathematics class. This is your foundation level. So last few days we have done things about binomial expansions, factorizations, algebraic fractions and some things about equations. And last week we did relations about quadratic equations, that is about general quadratic format. Then today I am going to do quadratic equation reduction thing. That means there can be some equations that can be reduced to quadratic patterns. Then all our quadratic patterns, by using substitution we can convert that into quadratic formats. So those things I am going to do today. Okay, then let's start from the beginning. Okay, let's start. See this one all. Here we have quadratic equations. We have quadratic equation ax squared plus bx plus c equals 0. Here general form. Ax squared plus bx plus c, general form of a quadratic equation. So there can be some equation which can be reducible to quadratic equation. So like here consider x to the power 4, 2x squared plus 1 equals 0. Here not directly quadratic, but it is reducible to quadratic. We can reduce to quadratic. So you take substitution, x squared equal t, then here t squared plus 2t plus 1. Now we can reduce that up to quadratic, okay, reducible type. Then you consider here this one, 2x plus 1 squared plus 3 times 2x plus 1 plus 1 equals 0. Here you get 2x plus 1 equal t, then here t squared plus 3t plus 1 0. Now that is quadratic format, okay, we can reduce to quadratic. You consider third, x plus 1 over x plus 3 equals 0. You multiply by x, then x squared plus 1 plus 3x, 0. Now it is quadratic, no? Now it is quadratic. Consider fourth relation. You consider 2x minus 1 square root, 2x minus 1 half, 2x minus 1 minus half, minus 2 equals 0, minus 2 equals 0. Then here you take substitution, 2x minus 1 square root as t, then here t, here 1 over t, or otherwise you can say t to the power minus 1 minus 2. Then here x to the power minus 1 plus constant type. Now we can multiply with t. Then t squared plus 1 minus 2t equals 0. Now it is reducible, no? That also quadratic format. Then you can follow this procedure, t plus 1 over t minus 2 0, then multiply by t, then multiply by t, then you get quadratic pattern. Okay, write down topic today. Equations reducible to quadratic equations. Equations reducible to quadratic equations. Equations reducible to quadratic equations. Okay, just write this. Ax squared plus bx plus c equals 0. Ax squared plus bx plus c equals 0 is directly quadratic equation. Ax squared plus bx plus c equals 0 is directly quadratic equation. directly quadratic equation. Directly quadratic equation. There can be some equations. There can be some equations which can be reducible to quadratic equation by using substitution. By using substitution. Okay. Just write these examples. Here 1, 2, 3, 4. Write examples. Then you have to think proper substitution. Okay, you have to think proper substitution. Then with the pattern you try to deduce a quadratic equation. You have to deduce quadratic equation. Okay. Now see this one. See this one all. Now here these are advanced type of equations, especially quadratic equation, advanced type of quadratic equations. Consider here this one, x to the power 1/3, x to the power 2/3, 3x to the power 1/3 plus 4 equals 0. That also you have to identify like quadratic. Here power 2, here power 1. Then you write here x to the power 1/3 square. X to the power 1/3 plus 4, 0. Let x to the power 1/3 equal t. Take this substitution, then put it here. Then t square plus 3t plus 4, 0. Now we had reduced that up to quadratic format. Okay, now that is in quadratic form. See another one, 2x minus 1. Before that, say x plus 3 root x minus 4 equals 0. Here x root x. Let root x equal t. Then square both sides, x equal t squared. Then put here t square, 3t minus 4, 0. Likewise, you can reduce, no? So, here reducible quadratic form by using substitution. Write examples. Okay, now see this pattern. 7, 2 to the power 2x, 3 times 2 to the power x minus 40. See this, here 2 to the power x to the power 2, here you can write this way, 3 times 2 to the power x minus 40. Now you get 2 to the power x equals t, then here t square 3t minus 40. Okay, so we have some index laws now. We have some index laws. A to the power b times c. We say a to the power b to the power c. A to the power b to the power c. Okay, then that's how we write 2 to the power 2x equal 2 to the power x to the power 2. Then here 2 to the power x there now, then you can put substitution. Now 8th one, 3 times 3 to the power 2 times 3 to the power 2x plus 3 to the power x plus 1 minus 1 0. Here 2 times 3 to the power x to the power 2, 3 times 3 to the power x minus 1 0. Now you better to get substitution. 3 to the power x equals 3 t, 2t square 3t minus 1 0, t equals 3 to the power x. Okay, write examples. Likewise you can reduce. Okay, you have to think substitution. You have to think substitution. Identify the patterns. There can be different patterns. You identify different formats. Okay. Now see this 3 to the power x plus 3 to the power minus x plus 40. Then here 3 to the power x, here 3 to the power minus x, 1 over 3 to the power x plus 40. Now you take substitution. 3 to the power x equals t, then here t plus 1 over t plus 40 multiplied by t, t square plus 1 plus 40 multiplied by t, then t square 140. Now it is quadratic form. Now do with me. Do with me. Okay. Now see this one. See this one. 10th one. X over x plus 1, x plus 1 over x plus 3 0. See this one all. X over x plus 1, x plus 1 over x plus 3. Here if you get this one as t, this will be its reciprocal, no? 1 over t. Then you get the substitution x over x plus 1 equal to t. Now put it here t, then x plus 1 over x, its reciprocal, 1 over t plus 3, 0. Then multiply all by t. Then t square plus 1 plus 3t. Other side 0. Now we have converted up to quadratic, no? So these are reductible quadratic formats. Reductible quadratic formats. Write it. Write it. Okay. Now you try to reduce these things. Do alone. You try this, huh? Do alone. Reduce them. If you can write directly, just write. Here substitution 2x plus 1 equal t, then t square plus 3t plus 1, 0. And here substitution x plus 1 equal t, then t plus 1 over t minus 4, 0, multiply by t, then t square plus 1 minus 4t, 0. And here proper substitution x plus 1 root equal t, then here t 1 over t plus 5, 0, multiply by t, then t square plus 1 plus 5t, 0. Here x over 2 equal t, x over 2 equal t, here t plus 1 over t minus 1, 0. Okay. Then multiply by t, t square plus 1 minus t, 0. Here x over 2 equal t, and here 2 over x, 1 over t, no? 1 over t. Okay, let's do further. You do alone. Take these questions. Question number 5. Okay, do them. Do them. Okay, here x over x plus 1 root t. Then here t plus 1 over t minus 2 0. Then quadratic format you can convert. Then multiply by t. T square plus 1 minus 2t 0. T square plus 1 minus 2t 0. Now here 3 to the power x plus 3 to the power 1 divided by 3 to the power x. Apply index laws. Apply index laws. Here subtraction, then here it is a to the power b times a to the power c equal a to the power b plus c. Then you can get converse. A to the power b divided by a to the power c equal a to the power b minus c. A to the power b divided by a to the power c equal a to the power b minus c. Then its converse is this. Okay. Then that's why here we write 3 to the power x, then 3 to the power 1 minus x, 3 to the power 1 divided by 3 to the power x equal to. Now you can take substitution 3 to the power x equal t. Take that substitution. Then t plus 3 over t equal to, then multiply by t. Then t square plus 3 equal 2t. Then t square plus minus 2t plus 3 0. Likewise, you can convert. Yeah, index laws. Continue, take little time further. Then see last two reduction, check your answers. Last two reductions. 2 to the power 2x plus 1, 3 times 2 to the power x minus 1 0. Then write here power plus 1, then 2 times 2 to the power 2x. Here this one. Then remove this 2 and put squared. 2 to the power x minus 1 0. Then 2 to the power x equals t, then 2t square minus 3t minus 1 0. Okay. Then 5 to the power 1 minus x, 5 to the power x plus 1 minus 2 0. Here 5 divided by 5 to the power x. Here index no. For index minus you can take in downstairs. Then here 5 to the power x times 5 to the power 1. Now take substitution, 5 to the power x equals t. Then 5 over t, here 5t minus 2 0. Now multiply by t. 5 plus 5t square minus 2t 0. Then 5t square minus 2t plus 5 equals 0. Likewise, we can reduce. Okay. Okay, now we have to solve equations. We have to solve these type of equations. Now you know linear type equation has only one solution. No? Linear means power 1 relation. Then quadratic type equation has two solutions. Then cubic type equation we have 3 solutions. Biquadratic type 4 solutions. It goes on. So here reductible quadratic format. These are reductible quadratic format. Here usually when you reduce that one, for that equation contain 2 solutions after reducting, okay. But original equation, this is original equation, can be different number of solutions. Identify. So after reducting we get quadratic. Then for this part we have 2 solutions. But for original one that can be many solutions. Or that can be no solutions. Okay. Okay, with star mark write down. Usually quadratic equation has two solutions. Those solutions can be first one, real. Those solutions can be first one, real. Okay, by the side write down real values. Here minus infinity to plus infinity. All values are possible here. Irrational values, rational values, fraction, some full values, integers. We can have any real value. Half, root 3, minus 1/3. Likewise, we have real values. Second one. Imaginary solutions. Imaginary solutions. Here 2i minus 5i. Put some dots. 1 over 2i. Those are imaginary solutions. So with I we write imaginary values now. Then for quadratic equation can get imaginary solutions. But usually we mainly concern about real solutions only. If we have imaginary solution, we know how to obtain that. But usually we think about only real solutions. Okay. Third, complex solutions. So we have identified those now. Then complex means combination of real and imaginary. 2 plus 3i. Half minus root 3i, root 3 over 2i. Likewise, these are complex solutions. So we have identified that imaginary solutions and complex solutions last day, no? Last day. So we obtain them when we have within square root negative value, we get imaginary, no? Okay. Put another star mark and write done. The result of square root of a negative real value, square root of a negative real value is an imaginary. Mainly we focus on real solutions only. Therefore, when solving equations, usually we eliminate non-real solutions. Usually we eliminate non-real solutions. Okay, better to underline that one. Eliminate non-real solutions. Very important point. Later we will discuss things about irrational equations. In that case, we discuss that one further. Okay. Now put another star mark. And write down. Usually denominator zeros are negligible. Usually denominator zeros are negligible. Of any expression. These denominator zeros are known as vertical asymptotes. ASYMPTOTES. Vertical asymptote. ASYMPTOTES. Vertical asymptote. Don't worry about that term, and later we will discuss that. Anyway, you have to remember this only. No need to remember that word for now, but we will discuss that one later. But anyway, you remember, if you have expression like 2 over x minus 1, you say here denominator 0, x equals 1. No? Here you have to remove. That is undefined. X equals 1 is undefined. We remove that one. 3 over x plus 1, x minus 1. We have denominator zeros, x equals minus 1, x equals plus 1. You have to remove that. Then 4 over x times x minus 1, 1 over x plus 1. Then here denominator 0, 0. and here 1 and here minus 1. All are negligible. Okay, all denominator zeros you have to remove. Then remember that one. Okay, so after you get in solution for equation, then we have to check whether it is correct or not using these two conditions. One is within square root you have to take positive values, and in original equation if there is denominator, then we have to remove denominator zeros. I will tell you how to do it. Okay, just put this on as examples. You have to remove denominator zeros. Further you write down, there can be equations, which are reducible to a quadratic equation. That quadratic equation contain two solutions. But original equation can be contain different number of solutions. Okay, now see what I am telling here. See this one. Huh? You consider x plus, see x to the power 4 minus 2x squared minus 30. Here example, I am going to solve this one. X to the power 4 2x squared minus 30. First, let's reduce this one. Let x square equal t. Then here, x square to the power 2 minus 2x square minus 30. Then here t square minus 2t minus 30. Now you have factors t, 3, 1 minus plus. Okay. Now we have two real solution for t. Take them. Then each factor you can equate to 0 now. Then t plus 1 0 or t minus 3 0. Then t equal minus 1 or t equal 3. So we have two solution for t. No? But we know t, that is x squared, no? then t equal x square, then x square minus 1. Then we know this one non-real solution, but anyway we can solve this. X equal plus or minus 1 root. Then plus or minus 1 root mean I. Then by this you get two non-real solutions. Then O, here t mean x square, no? X square equal 3. Then x equal plus or minus root 3. Then we get two real solutions. Two real solutions, two non-real solutions. Anyway, after reducing we get two solutions for t, but original equation can contain different number of solutions. So anyway, again check here biquadratic, no? Power 4 mean biquadratic. I told you biquadratic has 4 solutions. So we got 1, 2, 3, 4. 4 solutions. Okay, biquadratic contain 4 solutions. Okay, do that example. Okay. Now see another example. Take this. X over x plus 1, x plus 1 over x minus 2 equals 0. So by just simplifying you can obtain quadratic and you can solve it. But using substitution we can reduce that into quadratic. Now let x over x plus 1 equal to t. Then put it here t, here 1 over t, minus 2 0 multiplied by t now, t square plus 1 minus 2t. T square plus 1 minus 2t, then t square minus 2t minus 1, 0 plus 1. No? Then t minus 1 square 0. T square minus 2t plus 1 0. Then we get t equals 1. Then we have one solution for t. But it is repeated. Okay. Usually quadratic contain two solutions. No? Now here t equal 1. The other one will be t equal 1 again. Then two solutions. Then anyway t plus 1. T equal x plus 1. X over x plus 1 equal 1, simplify, x plus 1, here see 0 equal 1, Then here after reducing this you get solutions, but here wrong condition, no? Wrong condition means no real solutions for this, no real solutions. Okay, do this one. Here this side we call contradiction. Contradiction means cannot happen. Therefore, no solutions. no solutions. Okay, that's why I told you. After reducing into quadratic, we will get solutions, but original equation can contain different number of solutions. No? Here no solutions. Okay. Now see another example. X square plus 3x to the power 2 times x square plus 3x minus 3, 0. Here take this. X square plus 3x square, x square plus 3x minus t. Then the better substitution x square plus 3x, no? Then let x square plus 3x equal t. Put it here. T square minus 2t minus 3, 0. Then factorize t, 3, 1 minus plus 0. Then here t plus 1 equals 0 or t minus 3 equals 0, t equal minus 1 or t equal 3. T mean now x square plus 3x minus 1, x square plus 3x equal minus 1, then x square plus 3x equals 3. Now we have again two quadratic equations. No? They are in general form. Then you can solve them. No? Okay, continue. Now use direct formula to obtain solutions. These advanced types. Then final answer x equal minus b plus or minus b square minus 4ac root divided by 2a. Then minus 3 plus or minus root 5 over 2. Then here x equal minus b plus or minus b square minus 4ac root divided by 2a. Minus 3 plus or minus 9, 12, 21 root over 2. Likewise, you can get solutions. Anyway, we got 4 solutions here, 2, there are 2, all 4. Here, when you expand, you get biquadratic. Then biquadratic has 4 solutions. No? Biquadratic has 4 solutions. Now take your tutorial, page number 4. Page number 4. Page number 4. Now see example 3. See example 3. So I'll give you time later, but I'm going to discuss in this, okay? Then 3x square plus 3x to the power 2, 5x square plus 3x minus 6. Do with me. Then you get substitution, x square plus 3x equal t, then t square minus 5t minus 6 0, factorize t 6 1 minus plus 0 t square minus 6t 1 minus 5t minus 6, then t plus 1 0 or t minus 6 0, t mean x square plus 3x plus 1 0, yeah, x square plus 3x minus 6 0. Then each case you can write solution. X equal minus b plus or minus b square minus 4ac root divided by 2a. Here x equal minus b plus or minus b square minus 4ac root divided by 2a. Likewise, you can obtain solutions. Do soon. You can write final answer. Minus 3 plus or minus, here 9 minus 12 minus 3 root divide by 6. Here x equal minus 3 plus or minus 9, 24, 9, 33. Root divide by 2. Here x square plus 3x, no? X square plus 3x minus b plus or minus b square minus 4ac divided by 2a. Minus 3 plus or minus root 5 over 2. The procedure here, first you reduce to quadratic by using substitution, then solve it, then go to next solution of x. Okay, I'll do another one example only, then you can go to the questions. See, example 2, next one. Example 4. Here equation given here, 4x plus 5 over x plus 5 plus x plus 5 over 4x plus 5 equal 10 divided by 3. Then do with me. let 4x plus 5 over x plus 5 equal t. Here t. Then this will be 1 over t is reciprocal, no? 10 over 3. Then get common denominator, t square plus 1 over t, 10 over 3, then cross multiply, 3t square plus 3 equal 10t. Now convert into general quadratic format. Take here 3t square minus 10t plus 30, then factorize 3t, t, 3, 1 minus minus 0, then 3t minus 1, 0, o, t minus 3, 0, t mean 1/3, here t mean 3. Then we know t, put it here, for x plus 5 over x plus 5, 1/3 cross multiply, 12x, 15, x plus 5. Here 11x equal minus 10. Then possible x value minus 10 divided by 11. Minus 10 divided by 11. Similarly, here 4x plus 5 over x plus 5, 1, here 3, no? Multiply 4x plus 5, 3x plus 15, here x equals plus 10. Then we have two possible solutions. We have two possible solutions. As first step, you have to convert into quadratic by using substitution. Thereafter, find possible values, then go further. Do that as again example. Now go to page number 11 exercise. Page number 11 exercise. We have to solve equation, similar type equations. Okay, you try. For now you can do up to question number 14. You can do up to question number 14, but try first 3 questions only for now. Try first 3 questions. I'll give you a small time. Page number 11. Page number 11. Try first 3 questions. Do alone. Do alone. 2 alone. First you substitution, then find quadratic, then solid and go further. No hurry, take your time. Take time. First you try only first 3 questions. You can check your answers now. Without any error, try to do. Then go to question number 2. Question number 2, x square plus x square minus 9x plus 15. Check your answers. X square minus 9x plus 20 equals 6. 20 equals 6. Okay. Now, here you better take x square minus 9x plus 15t. Then here this one x square minus 9x plus 15 plus 5. Then here t plus 5. Then t times t plus 5 equals 6. Okay, then t square plus 5t, take this on the other side, 6, 0. Okay, you can't write t equals 6, t plus 5 equals 6. Only for 0 you can write t equals 0 likewise. Okay. Then the other values you can write t equals 6, t plus 5 equals 6, that is wrong. Then factorize t 6, 1 plus minus 0, t minus 1, 0, o, t plus 6, 0, t equal 1, o, t equal minus 6. Then you can proceed. T mean x square minus 9x plus 15 equal 1, or x square minus 9x plus 15 equal minus 6. Minus 6. Okay. then solve them. Continue. X square minus 9x plus 14, 0, we have factor here. X 7, 2 minus 0, x equals 2, x equals 7. We have two solutions for that. And further we have another quadratic, then you can get solution for that. Here x square minus 9x plus 21, 0. So here we don't have any proper factors now. Then x equal minus b plus or minus b square minus 4ac root divided by 2a. Then 9 plus or minus 81, here 84 minus 3 root divided by 2. Here 81, here 84 minus 3 root. Then we have two non-real solutions, especially two complex solutions. If you done first three questions, you can go further now. Do alone. Do without any error. There can be different substitutions, okay? But final answer must be same. There can be different substitution. Then question number 3, I'm going to use x plus 2 of x equal t. Then here t plus 4 times t minus 1, 6. Then t square plus 3t minus 4 equals 6. T square plus 3t minus 10, 0. Factorize tt 5, 2 plus minus t minus 2, 0 or t plus 5, 0. Then t mean x over 2, x plus 2 of x. Here x plus 2 of x plus 5, 0. Now we have done up to some level. Thereafter, you have to multiply each expression by x, no? Then here multiply by x, then here x square, this will be 2, here this will be minus 2x, 0, then x square minus 2x plus 2, 0, right solution, minus b plus or minus b square minus 4ac root divided by 2a. 2 plus or minus 4 minus 4 times 2 root over 2. 1 plus or minus 1 minus 2 minus 1 root. We get two imaginary solutions. Then take the other expression as well. Then multiply by x here. X square plus 2 plus 5x 0. X square plus 5x plus 2 0. Then x equal minus b plus or minus b square minus 4ac root divided by 2a. You practice formula. If we don't have any factors, you better to use formula. Then minus 5 plus or minus 25 minus 8 17 divided by 2. Check it. Do alone. Go further. Don't do any mistake. Try to do alone. First use substitution, then reduce to quadratic equation, solve it and go further. Take time. Okay, then question number 4. X over x plus 1 square 5x over x plus 1 plus 60. Then take substitution. X over x plus 1 equal t, then t square 5t plus 60 t 3 2 plus 0, then t equal minus 2 or t equal minus 3, then we know x over x plus 1 minus 2 x over x plus 1 minus 3. then solve. Cross multiply. X minus 2x minus 2, 3x equal minus 2, x equal minus 2/3, or x equal minus 3x minus 3, and 4x equal minus 3, x equals minus 3/4. Same method, na? Same method. Continue. Continue. Question number 5. 3x plus 7 power half x plus 7 power minus half equal 10. Then here x plus 7 power half, here take 1 over x plus 7 power half, remove this minus sign, equal to 10. Now let this substitution t equal x plus 7 power half. Then here 3 t 1 over t 10. Then multiply by 10, multiply by t, t square plus 1 10t. 3t square plus 3 equal 10t. Then 3t square minus 10t plus 3 0. Practice ella. Without an error, practice. Don't miss steps. Step by step you write all. Then later we can reduce all steps. Then proceed. 3t square minus 10t plus 3 0. So we did factorization technique to factorize these type of things. Here 9, 10. T equal 1/3, t equal 3. T mean x plus 7 root 1/3. Here x plus 7 root equal 3. Then square both sides. X plus 7 1 over 9, x plus 7 9, then x equal minus 7 plus 1 over 9, x equals 2. Then two possible x values, minus 62 over 9 plus 2. Continue. Do alone. Question number 6. Question number 6. Here given x plus 4 root x equal 12. X plus 4 root x equals 12. Okay, then you better to get substitution. Root x equal t, no? Then here this will be t square. Here 40. 12 take the other side. Then factorize. T 6 2 plus minus t square 60 2t 40 0. Then t equal 2 or t equal 6. Then root x equal 2 or root x equal minus 6. Yeah, this is very important one. Na? This is very important one. Check this one all. Check this one. So square root 4. Square root 4. Here only one solution is 2. Here there is only one solution 2. Then sign mentioned in here, it is plus. Then 4 outside minus. Then here only solution minus 2. 4 root equal to minus. Okay. Then if you go to here, root x equals 2, here positive, no? Here positive, they match, no? Therefore you can square this. X equals 2 square, value 4. Value 4. And there's special thing here. If you get any real value for x, you think values. So if you put here 36, if you get 36 here, then you can get 6, but not minus 6. Here because sign here plus, no? Sign here plus. Then if you have plus value here, you can't get minus result. If you have plus value here, you can't get minus result. Therefore, this is not possible thing. Then you say it is contradiction. No solution. That is very important. Na? This will miss. Then here root x equals 2, we have solution x equals 4. We can square both. But here root x equal minus 6, we don't have any real solution for x. We don't have any solution for x. Because we can't get this sign. We can't get that sign. But if you square this one, you can get 36. That is not our solution. Huh? You can't select that one. That is very important. Better note this one, because sign here plus, here sign here minus. If you put any negative value, we get imaginary solution. If you put negative value for square root, we get imaginary solutions. Negative, na? Negative root imaginary. We can't get minus value. Because sign here plus, we can't get solutions. Next. Question number 7. Question number 7. X 3 root 5x equal 50, no? X 3 root 5x equals 50. Then you can take substitution. Here take x plus 3 root 5 root x equal 50. Then take root x equals t. Then here this will be t square 3 root 5t minus 50. Then check factors t 3 root 5 now. Here 50 multiple 5 times 10 or 5 times 10 25 times 2. Likewise they have different multiples now. Then with irrational value you have to think. With irrational value there will be 5 here, there will be root 5. Then let's put here 5 2 plus minus 0. Now check t square 5 root 5t minus 2 root 5t 3 root 5t. Then 5 into 2 10 root 5 5 then 50. Now we have factors. Okay. Or otherwise if you can't see these factors, you know formula, you have formula, then substitute and find. We have two options. Then t equal 2 root 5 or t equal minus 5 root 5. Then t mean root x. Then here t mean root x. Then square both side 20. Here root x, here sign plus, here minus. It's contradiction, no real value, no solutions. You forget it. For that you don't have solution. For this you have solution 20. Here you can square, but here you can't square. Do alone. Okay, then question number 9. Question number 8, x to the power half minus x to the power minus half equal 3/2. X to the power half, x to the power minus half equal 3 over 2. Then minus half we can put downstairs without removing minus value. No? Then x to the power half, 1 over x to the power half, 3 over 2. Now take substitution, x to the power half equal t, then here t minus 1 over t, 3 over 2, t square minus 1 over 2, t equal 3 over 2 multiply 2t square minus 2, 3t. Then 2t square minus 3t minus 2, 0. Take steps, take steps and do that clearly. Then 2t t2 1 minus plus 0. 2t square minus 3t minus 2 no. So second day we done factorization technique. Then that is very important. Factorization very important, expansion very important. I told you to factorize these relations directly without any steps, because that is very small thing here. You have to practice that one without any steps. Then t equal 2t plus 1, 0 or t minus 2, 0, t equal minus half or t equals 2. Then t mean x to the power half, no? X to the power half mean root x, no? We know this one, contradiction. Then no solution for this. And here root x equals 2, this is possible. X equals 4. X equals 4 is possible. But here this one impossible. Take time. Okay. මේවා ටිකක් ඇඩ්වාන්ස් ටයිප් ඉක්වේෂන්ස් හරිද? ඒතකොට ඔයාලට කලින් හම්බුනේ නැති පැටර්න්ස් හම්බ වෙනවා. එකක් තමයි වෙන්නේ මේක. impossible. ගොඩක් වෙලාවට ඒ වගේ එකක් කේස් එකක් එන්නේ irrational equation with irrational equation. Irrational means with square root. Square root 1/4 power, 1/6 power. Okay. Not with 1/3, nah? With square roots, usually with square root. එතන ස්පෙෂලි මතක තියාගන්න. හරි අපි පොඩි රෙස්ට් එකක් ගමු නේද? පොඩි රෙස්ට් එකක් ගන්න. Okay, let's start further. Now we done about reduction of quadratic equation to quadratic, na? Reduction formats. Then we have different reduction formats. Let's do exponential type now. Let's do exponential types. Take your tutorial. Take your tutorial. See, page number 6, example 7. Page number 6, example 7. Page number 6, example 7. I'll do this. Here given part A, 2 to the power 2x, 3 times 2 to the power 2x plus 2, 2 to the power x plus 2, 32 equals 0. Okay, that is exponential type. Previously we have analyzed how to reduce that using substitution. No? Okay, I'll do this one. 2 to the power x to the power 2, here 3 times 2 to the power x times 2 square, 32. Then let 2 to the power x equals t. Then here t square, 3, 4, 12, t plus 32, 0. Now you factorize t, 8, 4, minus, 0. Okay. Then here t equal 4 or t equals 8. And further we know t value 2 to the power x. No? 4 means 2 squared. 2 to the power x equals 2 cube. Now you can equate indices. Then x equals 2 and here x equals 3. We have two possibilities. Equate indices. That's how we solve exponential equation. Anyway, by using initial substitution, you convert into quadratic, then solve it, thereafter go to final answer. Final answer. And remember, this is very important. If you have a to the power x equal a to the power b kind of thing, then you can equate indices. X equals b. Then base same, then indices must be same. Exponent must be same. Then a to the power x equal, here let's put 2, 2 here, 3. Then x equals 3. Likewise. Then 2 to the power x equal any other thing. Here base 2, no? Then if you have 3, then we have logarithms to subject x. Here we have subject x equal log 2 base 3. X equals log 2 base 3. You remember this one, but anyway we do, when we are doing logarithms, we do that type of relations. So we have theorem, this has done your O levels, then x equals log 2 base 3. That's how we subject it. But here base same, you can directly equate indices. X equals 3 is the solution. Here x equal log 2 base 3. Here 1, 2. Then there's another important thing. 2 to the power x equal minus 1, minus, let's say minus 4. Here sign plus, no? Then here by changing this exponent, we can't get any negative value. We can't get negative value. Because if you put 0 value, 2 to the power 0, 1. If you put positive value, 2 to the power 1, 2, 3, 4, we don't get negative value. If you put negative value here, if you put negative value, say 2 to the power minus 1, then 2 to the power minus 1 means 1 over 2. 1 over 2, no? Then 1 over 2 surely positive, ne? Then all exponentials are positive. All exponentials are positive. Therefore, here minus results we can't get. Say it is contradiction. No real solution for x. It's also new to you. It's also new to you. Okay. These are exponential equations. Here exponential equation, use substitution to convert into quadratic, then solve it and subject x. When subject in x, you have three different cases. With same bases, you can equate indices. With different bases, you can subject x using logarithm. For negative value, you say there is no real solution. We don't have any real solution. Okay. Do this example and by the side put this note. This is very important. Huh? But for today, we can obtain here this one or these two only. Later we will discuss this one. See another example. See another one. 3 to the power x minus 2 plus 3 to the power 3 minus x equals 4. 3 to the power x minus 2, 3 to the power 3 minus x equals 4. 3 to the power x minus 2, 3 to the power 3 minus x equals 4. Okay, check this one now. Here second example. So anyway, you identify that is exponential type. The specialty of exponential function, index has variable. Index has variables. Okay. Then this case, you write this 3 to the power x here minus no minus you write as division. Here 3 to the power 3 minus write as division. Now get substitution 3 to the power x equals t. Then here t over 9. Here 27 over t 4. Then get common denominator. Here t square 9 into 27. 90 equals 4. Then t square 9 into 27 36 t. Then we have quadratic relation. Now we can solve. No? Okay, start it now. T square minus 36t 9 into 27 equals 0. Here 9 plus 27 36 now. We had done factorization technique x square minus x alpha plus beta x plus alpha beta 0 type x minus 9 x minus 27. Here not x, that is t. Therefore t equal 9 or t equal 27. T mean 3 to the power x, 9 mean 3 square. 3 to the power x, 3 to the power 3, equate indices. X equals 2, x equals 3. Like that we do. First you get substitution, then convert into quadratic, then factorize and go for answer. Okay, then page number 11 exercise. Page number 11 exercise, you can do 4 questions. Question number 22, 23, 24. 22, 23, 24 and 28. Okay, start now. Take time. 22, 23, 24, 28. These are exponential types. No hurry, take your time. Definitely for your term test, first term test, there will be exponential type equations. And also exponential type equation can be in your A-level question as well, but not always, but there can be. Then later we will discuss exponentials and logarithms. So in our A-level syllabus also we have exponentials and logarithms, but here little thing about exponential equation. We have in many other things to discuss under exponentials. Okay, start. Page number 11. Page number 11, 22, 23, 24, then 28. Those are exponential types. Start. Okay. 22. Check your answers. 3 to the power x plus 2 plus 3 to the power minus x equal 10. Then 3 to the power x, 3 square, 1 over 3 to the power x, 10. Then 3 to the power x equals t, here 9t. 1 over t, here 10. Then multiply by t, 9t square plus 1, 10t. Then take one side. Then factorize. 91 t1 minus minus. Then t equal 1 over 9 or t equal 1. T mean 3 to the power x, 3 square take upstairs, 3 to the power minus 2. Then equate indices, x equals minus 2. Then here 3 to the power x equals 1. 1 you write 3 to the power 0. Then 3 to the power 0 equal 3 to the power x equals 0. X equals 0. Same procedure. Same procedure. Do alone. Then 23, 5 to the power x, 5 to the power x plus 1, 5 to the power 1 minus x equal 5 to the power 2 plus 5 to the power 0. Then write here 5 to the power x times 5. 5 divided by 5 to the power x, here 25, 5 to the power 0, 1. Let 5 to the power x equals t, then here 5t plus 5 over t equal 26. Multiply by t. 5t square 5 equal 26. T, take one side. 5t square minus 26t plus 50, then factorize. 5t, t, 5, 1 minus minus 0. Then t equal 1/5 or t equals 5. Then 5 to the power x, 1/5 means 5 to the power minus 1, then x equal minus 1. Here 5 to the power x equals 5 to the power 1, then x equals 1. Then we have two solutions, plus 1 and minus 1. Continue. Okay, then 24. 4 to the power 1 plus x, 4 to the power 1 minus x equal 10. Okay, then here 4 times 4 to the power x, 4 divided by 4 to the power x, 10. Let 4 to the power x equals t. Then divide by 2, 5, 2, 2. Then here 2t, 2 over t, 5. Multiply by t. 2 square plus 2 equal 5t. Take one side. 2t square minus 5t plus 2. Then factorize. 2t, t, 2, 1 minus minus 0. Okay. Then t equals half or t equals 2. Here 2 to the power x. Here 1 over 2 means 2 to the power minus 1. X equal minus 1. 2 to the power x equals 2 to the power 1. X equals plus 1. here small error, 4 to the power x. No? Here 4 to the power x equal 2 to the power minus 1. Then 2 square x. Then 2x equal minus 1. X equals half. Here 4 to the power x, 2 to the power 2x 1, 2x equal 1, x equal minus half and plus half. Minus half plus half. Huh? Do alone. Then 28. Question number 28. Here given 2 to the power 2x plus 3, 65, 2 to the power x minus 1 plus 57. Then write here 2 to the power 2x, 2 cube, 65, 2 to the power x minus 65 plus 57. Then here 8, 2 to the power x to the power 2, 65, 2 to the power x, here 65, 57, 5, 7, 8. Then let 2 to the power x equals t, then 8t square, 65t minus 8, take one side, t, 8, 1 minus 0. Then 8t equal 1, t equal 1 over 8, or t equals 8, t mean 2 to the power x, 1 over 2 cube, 2 to the power minus 3, x equals minus 3. 2 to the power x, 2 to the power 3, x equals 3. We have two possibilities. If you have any doubt, repeatedly do these questions. Huh? First identify fundamentals, then simplifications, then reduction thing, and then you can simplify. Okay, now you come to page number 11, question number 14. Page number 11, question number 14. Start it. Page number 11, question number 14. So that is belongs to previous type. That belongs to previous type, but I need to change that type. Do question number 14. One over x equals t. Substitution x minus 1 over x equals t. Convert into quadratic, then try to factorize. Two t plus 3, 2t minus 17. Here 40 square, 34 minus 6, 28, 51. Then t equal minus 3 over 2 or t equal 17 over 2. Continue. first case you have factors, but the other case we don't have proper factor, no? Then we have to apply that formula. Then here 2x square minus 17x minus 2, x equal minus b plus or minus b square minus 4 ac. Root divide by 2a. Then you can simplify here 17 square two 16. Three 305. Take time. Something wrong here. Here plus 28. Plus 28. Here plus minus plus minus minus plus minus half plus 2, then minus 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 plus. Check that one. Minus b plus or minus b square minus 4ac divide by 2a. This is okay. Minus 17. Now last pattern for today. Last pattern. Check this one. Now see question number 15. Don't do, but just see. Question number 15, 16, 17, 18, those things belongs to here. Check this one. You consider x plus 1 over x equal t. So when we are doing binomials, we done that simplification. Check this. So if you get square, both sides, if you get square, then x plus 1 over x to the power 2 equal t square. Okay. Here binomial, power 2, then we have 3 terms now. Square 2 into x into 1 over x plus 1 over x squared equal t squared. Now simplify. Here x squared plus 2 plus 1 over x squared equal t square. Put this to other side. Then x squared plus 1 over x square equal t square minus 2. Then here x plus 1 over x equals to t. Then x squared plus 1 over x square equal t square minus 2. T square minus 2. Okay. Then using this relation we can get substitution. There's another one. So if you have x minus 1 over x equal t, you square both sides. X minus 1 over x all things square equal t square. Expand, here power 2 binomial, we have 3 terms. X square minus 2 times x times 1 over x plus 1 over x square equal t square. Then x square minus 2 plus 1 over x square equal t square. Then subject these two only. Then x squared plus 1 over x square equal t square plus 2. Then when x plus 1 over x equals t, sorry, x minus 1 over x equals t, corresponding x square plus 1 over x square equal t square plus 2. T square plus 2. Then if you get this type of substitution, then x square plus y square will be t square minus 2. If you get this type of substitution, then x squared plus 1 over x square will be t square plus 2. Plus 2. Okay? That is very important. Then I'll do one example. Go to page number 5, example 5. Page number 5, example 5. Page number 5, example 5. Okay, see this one now. Here given 6 x square plus 1 over x square plus 35 x plus 1 over x plus 62. 0. Okay. Then when you see this one, here this will be our t term, x plus 1 over x. Then if you get that t term, x plus 1 over x equals t, if you get that x plus 1 over x equals t, then you say x squared plus 1 over x square equal t square minus 2, no? T squared minus 2. Okay. These are very important relations, you have to remember. Then here you put 35 t 62. Let's write substitution first. X plus 1 over x equals t. Then here 6. We know t square plus x squared plus 1 over x square t square minus 2. Here this one t square minus 2. 35t plus 62. Then 60 square 12, 35, here 50, 62 minus 12, 50. Now factorize. Okay, let's start to. First you write here first this relation, we have done this before, but anyway just write that one first. Okay. Now take this example and complete it. Same substitution. X plus 1 over x t, then x squared plus 1 over x squared t square minus 2, and here factor. Here 2x, 3x, here 5, 10. Ten, 5 plus 6 t na. Okay, then t equal minus 5 over 2 or t equal minus 10 over 3. T equal x plus 1 over x t. X plus 1 over x minus 10 over 3. Now we can continue. අර කලින් ඒවල නම් අපිට ලස්සන්ට මේවා පේනවා මේ පැටර්න් එක. හරිද? මෙතන එක සැරේ පේන්නේ නැහැ. සමහර කට්ටියට මේක වැරදියට පේනවා. හරිද? මේක t කියලා ගත්තම මේක t square කියලා පේනවා. ඒක වැරදි. Here t not, this is not t square, that is t square minus 2. T square minus 2. Okay. Here not perfect square, no. X squared plus 1 over x square is not x plus 1 over x whole thing square. That is wrong. Now continue. Two x square plus 2 minus 5x, 2x square plus 5x plus 2 0, 2x x 2 1 plus 0, minus half 4 minus 2, 3x square plus 3 minus 10x, 3x square plus 10x plus 3 0, 3x x 3 1 plus x equals minus 1/3, x equals minus 3. Two possibilities. Altogether 4 possibilities. Okay, you try. Question number 16, page number 11, question number 16. Okay, do alone. Do alone. Okay, then today we completed the things about equations, especially reduction thing about quadratic equations. Then you can do questions in page number 11. Page number 11 up to question number 21 you can complete up to question number 21, but don't do question number 25, 26, 27. Then next day we can go simultaneous equations. Then that is the end of our foundation course. Then thereafter we can start our new syllabus, or your A-level syllabus from the beginning with PO1. Okay. Then that's all for today. See you then. Bye.